So using operators is especially important for complex workloads such as Kubeflow. So please welcome Andreea, introducing the operators for Kubeflow on Kubernetes for all of us. Thank you.
Thank you, Cedric, for introducing me. I'm Andrea. I'm the MLOps product manager within Canonical, looking after our product, or actually portfolio strategy. And today I will be talking about the problems that MLOps solves and how operators can help you. For those who don't know, MLOps comes from machine learning operations, and I usually define it shortly as DevOps for machine learning. It is a practice that enables collaboration between different areas of the business in order to develop and ship machine learning models to production in a reliable and portable manner. So I would suggest we get started right away with Canonical's mission in this area, and what we are working on is creating a scalable MLOps platform that's available in one command, so that any AI enthusiast who is playing around can use our models, but also if they want to scale their initiatives, they can easily do it and move their artifacts around to scale them up. Of course, we're using open source tooling. That's part of our DNA. And let's not postpone it too much. Today we're talking about problems that MLOps solves, right? We already defined it. It's strongly related to AI/ML. And these days, I think everyone is talking about ChatGPT, Midjourney 4, I don't know, GPT-4 as well. So what are the problems that it solves? Well, MLOps firstly solves the sticky note problem. And in case you're wondering what's the sticky note problem, you have to think of companies that have bigger teams, more than 10 people, and they actually share the infrastructure underneath. How do they do that? Well, by now you might guess, they use sticky notes or maybe whiteboards. Anyway, they use all of these quite manual tools for innovative projects in order to schedule the usage of the infrastructure. What does it mean? Well, it overcomplicates the entire process, slowing down project delivery and often leading to other utilization of the infrastructure. It makes the AI initiatives have a lower return on investment than usual. So companies are usually looking for solutions or alternatives that could maximize the infrastructure power and could help organizations benefit from support. Of course, security is an important topic when we discuss about MLOps because it uses data, and data can often be quite sensitive. So Canonical's solution for this is having a foundation on open source machine learning operations tooling that we will be discussing a bit later. It's called Charmed Kubeflow, and I think it's quite a nice project that uses operators. The cloudy problem is not because it's just rainy, even if this problem can easily turn into a gloomy, challenging for a lot of organizations that have been growing by acquiring other smaller companies that previously used different clouds. For the big enterprise, it translates into having data in various places, and utilizing it for any project means connecting these dots. If we take an example, a company that has data living on a cloud A that acquired another company that has data living on a cloud B, if the big company would like to do any machine learning project that uses both of these data sets, what the organization actually needs is tooling that supports hybrid or multi-cloud scenarios, depending on where the data lives, if it's private or private cloud. And also, it requires a lot of flexibility in terms of integrations with different tooling. The security story still stays here as well because it's an important topic. And we will move next to the third challenge, which is, I think, the one that a lot of respondents reported on Canonical's social media as well. When it comes to AI/ML, the biggest challenge is actually to get started. You have the data, you could benefit from it, but also often it feels overwhelming because the project seems too complex, the data seem too complex as well. So what organizations are looking for actually is options and guidance on how to get started, as well as optimization opportunities in their data collection process, because raw data is the heart of any AI initiative. For a very long time, it was not that important on how we collect it, and these days it is often unclean. Last but not least, if we think of very complex projects such as self-driving cars, having smaller POCs and breaking the big project into smaller ones is essential. And I already mentioned this, but in order to address all these problems, usually you need an end-to-end MLOps platform that can cover the entire machine learning lifecycle. Charmed Kubeflow is Canonical's official distribution of the upstream project that was started by Google a few years ago. These days it's part of the CNCF, and it is an end-to-end open source MLOps platform that runs on top of Kubernetes, and it automates the machine learning workloads, allowing data scientists to focus on modeling rather than integrating with a lot of tools, juggling between them, and so on. The main advantages of the tool are that it actually can run on any cloud. So if we go back to the cloudy problem, it addresses this challenge quite easily. And furthermore, it supports hybrid or multi-cloud scenarios quite quickly, as long as there is a Kubernetes layer in between the cloud and the application, which is usually, actually always, the case. And then it is integrated with resource schedulers, such as Volcano. So if we go back to the sticky note problem, that goes away as well. And if we also consider the strong partnership that Canonical has with NVIDIA, and then the testing part that Kubeflow does with NVIDIA as well, we can also easily mention or add the power maximization that we are focusing on. And last but not least, we mentioned the lost in the woods problem, and you might wonder, well, how does it help me get started? Well, first of all, it covers the entire process. And if I did not mention already, what Charmed Kubeflow is a suite of tools that includes also Jupyter Notebooks, which is, I think, by far the preferred option when it comes to experimentation. So you can easily get started there. And with this, I'll move forward to, well, I will actually restate our mission. We want to have a scalable platform that is available in one command, and it enables data scientists or machine learning engineers to quickly develop models and move them or scale them up within one command. And this is why it's important to mention the composable bundles and the advantage of operators, right? Well, I mentioned as well that Kubeflow is a suite of tools, which is actually a suite of operators that can be bundled together differently. And by using Juju, we can run it on any environment. We can run it on public clouds. And if you look up on the internet, you'll find how to run Charmed Kubeflow on EKS, actually. But you can also run it on private cloud, and that's not a problem as well. Because of the way that Juju is built, also, it can easily connect these dots and list hybrid cloud scenarios. That goes back to the cloudy problem. It's solved by far. And furthermore, which is even more interesting, is that we're having Kubeflow as being able to run on all these different environments, it easily integrates with other tools. So by now, the way that we define Charmed Kubeflow is as the foundation of a growing MLOps ecosystem. So it is integrated with Spark, with MLflow, with MySQL, are just a few of the examples. And the mains or the tools that are available keep growing because it is a landscape that evolves quite quickly. But going back to the operators and why it's important to have composable bundles, it's quite easy. You can run it anywhere. And by now you might say, well, it's not possible to have it anywhere. I'll say you're not right. It is possible. Initially, Kubeflow has been designed as a product to run machine learning workloads at scale, to deploy them to production, and it works great for it. this is what it is for. But if we go back also to the idea of having it as a suite of products, we can easily debundle or rebundle them and have some parts of them together for different purposes. On the desktop, you might not need to have serving, for example, because you use it just for experimenting. So having model registry and Jupyter notebooks can be enough. So you need a few operators that need to be related using Juju, and that's it. You deploy them, you play with them, and also you can have, or you should have, a storage where you store your models such that in case you need them at scale, you move them to the storage. I also have their inference because I think these days having machine learning at the edge is quite a hot topic. And we wrote already quite a comprehensive guide on Medium. You can look it up on Ubuntu AI on how Seldon and Istio can be bundled together to run AI at the edge. But at the end of the day, it's the same big platform, which is Charmed Kubeflow, that is being rebundled in different ways. And to wrap it up, not to make it any longer, I'll simply say that Charmed Kubeflow is canonical open source MLOps platform that plays the role of the foundation. And it enables data scientists, machine learning engineers to run AI or to try AI anywhere, from experimenting on a laptop to scaling on big projects, on big clusters, quite easily. It is adaptable enough to run on Kubernetes and not just Canonical's Kubernetes. And it is nice that it gives access to a bunch of data and machine learning tooling, such as Seldon, Canonical's observability, Stack, PyTorch, Triton, are just a few examples. And at the end of the day, it covers the entire machine learning lifecycle, such that users don't have to struggle and to jump at anymore between tools. They have one, it works quite fine. And depending on their needs, they adjust the bundle itself. So to stay on time, because I don't have much left, and to conclude, actually, Canonical's MLOps OpenStack is open source, which is very important. I think it's in our DNA by now. And whenever you say Ubuntu, you say that. But except for that, it is able to run on any cloud, and it can also benefit from a rich integration ecosystem. I've already mentioned a bunch of tools. It is really the path to production. From experimentation to production, the entire lifecycle is covered. It is quite easy to use. It is community driven. It is not a fork of the upstream project. It goes hand in hand. We release at the same time. We work with the community, and it ensures security of the model, of the data, of the infrastructure underneath, which I would say is quite important. And I think that's it from my side. MLOps solves tons of problems when it comes to running AI at scale and moving machine learning models to production. And operators can help you rebundle the tooling depending on your needs. Cedric, I think that's it on my side, and I need to pass it back to you. Thank you very much.